We are going to solve some word problems with quadratics. So we did a whole bunch of linear ones. Today we're going to use some of your quadratic equation solving skills. So we have the difference of the squares of two positive consecutive even integers is 84. So positive consecutive even integers, consecutive means like in a row, and they're even. So if I go to find some variables here, we would like to keep it to one variable if possible. So I'm going to call my first number x, and then the next positive even number you get by adding 2 to your first number. Like if you're at 4, to get to the next even number, you add 2 and you get 6. So my two consecutive even numbers are x and x plus 2. I'm talking about the difference of the squares of these two numbers being 84. So difference means I'm going to be subtracting my squared values and getting 84. If I'm going to get a positive 84 when I subtract these two squared values, that means that I need to take my bigger value minus my smaller value. Otherwise it would come out negative, not positive. So when I set this up, if you think about which value is going to be bigger, if I square my larger number, which is x plus 2, that's going to be bigger than squaring my smaller number, since these are positive even integers. My equation, if I set it up and multiply x plus 2 times itself, and then do a little bit of solving, I'm going to have x squared plus 2x plus 2x give me 4x in the middle, plus 4, minus x squared equals 84. The x squareds are going to subtract off to 0, so then it just turns out to be a linear equation. 4x plus 4 equals 84. Subtract 4 from both sides, and then divide by 4. You're going to end up with x equals 20. So make sure you answer your question. It asks for the integers. So my first is going to be 20, and then my next one is 22. So 20 and 22 are the two integers that meet our requirements. We did some of these with squares whenever you were working with linear equations. We're going to do some with quadratics. So we've got two squares. The length of each side of a square is 3 centimeters more than the length of each side of a smaller square. So like usual, I like to draw some pictures on these. So here is my smaller square and my bigger square. It says the length of one of these squares is 3 centimeters more than the length of each side of the other. So there's my 2. And then I'm told that the sum of my areas is 149 square centimeters. So if I add up the area of the small square plus the area of the bigger square, I should get a total area of 149 centimeters squared. So area of a square is just side length times side length. So if I multiply my side lengths together, x plus 3 times itself gives me x squared plus 6x plus 9. And then x times x is just x squared. So if I plug in my areas, it's just going to give me a good old quadratic equation to solve. So combine some like terms, 2x squared plus 6x plus 9 equals 149. I could do quadratic formula, I could probably factor, I'm going to complete the square, because it looks like it'd be decent to complete the square on. If I do complete the square, that means I need a coefficient of 1 on my squared term, so I'm going to divide everything by 2. Completing the square is kind of my favorite. And then I need to figure out what it will take to complete the square. So this is going to be a very sloppy diagram here, but I have x squared plus 3x. So if I cut my 3x in half, I'm going to have 3 over 2x or 1.5x on each side to make my sides the same. So to complete that little corner there, my area that I need is 3 halves times 3 halves, or 1.5 times 1.5, which is 9/4. So add that to both sides to complete my square and keep my equation balanced. And then if I rewrite it as side lengths times side length, or in factored form, it's going to be x plus 3 halves squared equals 289 over 4. And if I take the square root of both sides, it comes out nicely as 17 over 2. So think about the positive and negative version. If you do x minus 3 halves plus 17 over 2, you get 7. And if you do the subtraction one, you get negative 10. Now in the context of our situation, we can't have a side length of a square that's negative 10, so only 7 is going to work. It asks the lengths of the sides of the two squares, so we have a 7 by 7 and a 10 by 10 centimeter square. Okay, we've got a particular landscaper who likes everything set up precisely. They are going to plant a 9 by 5 flower bed with 2 colors of flowers, one in the middle and one on the outside as a border. So the flower bed outside I've drawn here, it's a 9 by 5 foot flower bed. And then this is my border flower color in orange here. So I've got this border of colored flowers around the outside and then a different color of flowers in the middle. We know that we have enough plants to cover 24 square feet for the border, and we're trying to figure out how wide that border in orange is going to be. It is equal side lengths around the whole thing, so if you think of its mystery width and height depending on your angle as x, it's the same all around. So I need to think about the area that the border is going to take up. I could write an equation that represents this situation in a couple ways. I could say that if I take the area of the whole bed minus the area of the middle, I would get the area of my border that I know. Or you could think about the middle colored flowers plus the border flowers on the outside would get me my total area of the whole flower bed. I think I'm going to use that equation because it involves addition instead of subtraction, so maybe less opportunity for mistakes. So my border area is 24 square feet. The area of the middle, which is in red over there, we're going to have to think about our dimensions. So it's like 5 feet minus my border, which is x on either side, so 5 minus 2x, and then 9 minus 2x for my side lengths of my red rectangle. I'd multiply those together to get its area, and then the area of the whole flower bed, since it's 9 by 5, would just be 9 times 5. If I multiply some things together here, 45 minus 18x minus 10x plus 4x squared plus 24 equals 45. I noticed that there's 45 on either side of this equation here, so if I subtract 45 from both sides, that'll just get me 0. And then I can combine some terms and end up with that equation. Let's rearrange so it's in the order that you're used to. And then how about we factor out a common factor of 4? That's always a good plan. And then if I take my x squared minus 7x plus 6, I believe that should factor. I know you have to have an x and x, and then minus 6 minus 1 would get me a negative 7x in the middle and a positive 6 if you multiply them together. So I end up with x equals 6 and x equals 1. Now, those both seem like reasonable borders, except if you think about x equals 6 and plug it back in to the dimensions of my red area in the middle, that gives me a side length of negative 3 for planting my flowers in the middle, which doesn't make sense. If you use the 1 though, it works, and you have a 7 by 3 area in the middle to plant, and then your 9 by 5 area outside. So x equals 1 foot is your border that actually works. Alright, we've got this product that's supposed to be packaged in a cylindrical container, so think like a container of oatmeal, maybe? And the surface area of this package that they're creating is going to be 16 pi square feet. We're looking for the radius of our circular top. So surface area of a cylinder, formula is up there, 2 circles plus your rectangle that's rolled around the outside. We can plug in what we know, which is our surface area of 16 pi square feet, and our height is 6. And that is going to give us a kind of messy looking quadratic equation. There's a lot of pi's involved, your variable is r instead of x, but we still want to get 0 on one side. Remember, pi is just a number, it's a constant, it's not a variable. So if you subtract over your 16 pi and get 0 on one side, then we can use one of our mini quadratic solving methods. Let's see, it's a lot easier if you factor out your common factor of 2 pi, and then we can focus on what makes r squared plus 6r minus 8 equal to 0. That's not going to factor, so we're going to do some quadratic formula. You could do quadratic formula with your pi like in there instead of factoring out the 2 pi, but it makes it a lot messier and easier to make mistakes. So I'm going to plug in my coefficients into my quadratic formula. Inside my radical, I'm going to end up with 36 minus negative 32, so plus 32, 68. Not a perfect square, so I'm just going to leave it square root of 68 actually, and I'm going to round this off since it's like dimensions of something. I feel like if I was manufacturing this, I probably would just want it rounded. If I do the subtraction one, it's going to give me a negative value, so I will ignore that one. If I do the addition one, let me pop up Desmos here. If you're putting this into your calculator, either put parentheses around the negative 6 plus square root 68 if you're typing it all in at once, or just do the top and then use your answer key and then divide by your 2. That's what I'm going to do. So it looks like the radius is going to be approximately 1.123 feet.